All right, so today we are taking a look at solving three equation systems. So by the end of this lesson, you should be able to solve a system with three variables using both substitution and elimination. You generally have to use both of them throughout, going back and forth. And then in the end, we're going to apply this to a real-world problem. All right, so taking a look at our first example here. And as we can see, we do have three equations with three variables. If I have three variables, I have to have three equations. So they both go hand in hand. I'm not going to lie, these can be a little bit tricky, but you've got to be patient with yourself and just kind of work them like a puzzle, right? We're putting the pieces together. And just like our two variable, two system equations, you and your partner or fellow student could be working these, do it completely different ways and still come up with the same answer. So I'm showing you one way. You could work this on your own and do it in a completely different way. So just take that into note. All right, so the first thing that I always do when I've been given a system like this is I look for any variables that are easy to eliminate right away. Right? I want to look for something that's positive and negative and the same coefficient. And when I look at all of these, here I have these two y's, one's positive and one's negative, so they don't go away right away. So I know I'm going to have to make a couple adjustments. Well, what I also notice is that if I take this top equation and the fact that I have my x here that's negative and down here he's positive and then the opposite for y, I'm going to go ahead and I'm going to use both of these and I'm going to multiply the first one by 2. If I do that, I'm going to be able to get rid of x and y right away, which is a nice bonus. It won't always work out this way, as you will see as we move on, but for this one, it works out really well. So let me go ahead and multiply this top one by 2. So if I do that, 2 times that negative 1x is going to give me negative 2x. 2 times that y will give me 2y. And then 2 times the negative 3z will give us negative 6z. Now we have to go over the equal sign, right? I can't just do something to one side of the equation, so we need to also multiply the negative 4 by 2, which gives us negative 8. All right, now we're ready to bring down that bottom equation, and just as we did with our two variable, two equation problems, I need to add them together. So I'll go ahead and put my line under, and just like we said would happen, we get rid of both x and y. All right, from here, if I add the negative 6 to the 5, that's going to give me negative z, and then negative 8 plus 7 gives me negative 1. So it looks like z equals 1. All right, so we have one variable. Feeling really good about this. Our next step. From here, I have to use the equation that has not been used yet. Okay, we can't just stick with two equations and expect to get a good answer. So the one we haven't used yet is this guy right here. Now who I decide to pair him up with is up to me. Okay, it doesn't matter, but I do need to use him. I'm going to go ahead and I'm pairing him with the top guy here because I've noticed that if I again multiply by 2, as well as I'm going to replace the 1 with z, that really doesn't make any math for me. You'll notice we did it to this one already, so I'm getting the same equation plus multiplying by 2 is super easy. Okay. The only difference is going to be instead of having a z here like I do in this one, then I'm just going to have the negative 3 that I'm going to multiply to the 2, so just the negative 6. All right, so if I multiply by the 2, we get our negative 2x plus 2y minus 6, like we said, is equal to negative 8. And I will go ahead and bring down the guy in orange because, again, we haven't used him. Please notice that I went ahead and I plugged in 1 for z there as well, which just left me the 8. All right, so we have z's answer. We're getting ready to get rid of y, so this should leave me with the result for x. So let's go ahead and add them together. All right, so let's see, negative 2x plus 3x, that's just going to leave me x. 8 minus 6, that's 2, and 14 minus 8, that's going to be 6. All right, I need to subtract the 2 from the 6 to get my final answer for x here. So it looks like we get x is equal to 4. We're home free from here. Now all I have to do is pick one of these equations, substitute in x and z, and we'll solve for y. I'm again going to go with this top equation, and it's mostly because he's the easiest one. Both x and y do not have coefficients, so the numbers are nice and small, making the math very easy. All right, let's see. Cleaning this up, I'm going to have negative 4 minus 3, so that'll be negative 7. And when I add the negative 7 over to the other side, or I guess change them to positive 7, so add, we're going to get that y is equal to 3. All right, we have our solution. But just like our two variable, two equation systems, I have to write these as a solution as an ordered, not pair this time, but ordered triplet. So we always put this in alphabetical order, so it's X, Y, Z order. So we have our solution of 4, 3, and 1. Let's take a look at another one. So again, my first order of business is to see if there's anything that I can eliminate right away. And on this one, we did get lucky. We can without making any adjustments. Hopefully you noticed that these z's are going to go away very easily for us. So I'm going to use these two equations, and I'll bring them down, and I'm going to add them together. Z's go away just like we said they would. And from here, I'm just adding. So it looks like 15x plus x, that's going to give us 16x. And then let's see, 4 and 6 is 10, so 10y. And then 12 and 16 is going to give me 28. All right, now comes the time where I have to use the one I haven't used yet. So that is going to be this guy right here. So again, always have to use the one that you haven't used. Now I do need to keep in mind that I'm going to have to eliminate the same variable. Okay, so I'm going to go into y a little bit more in a second. So just kind of keep that in mind that that's what we're going to be doing. I'm going to go ahead and pair them with this guy right here. Knowing that I'm going to eliminate z because that's what we eliminated right here, okay, I'm going to go ahead and again multiply that top one by 2. All right, so if I do that, I'm going to get 4x plus 2y minus 2z is now equal to 10. And I'll bring down that second equation. We'll add those together. Z's go away as planned. And it looks like I will have, what, 5x plus 6y is equal to 26. All right, I'm just going to shift these closer to fill in this space, and I'm going to take away the purple. And now what I'm going to do is use these two equations with two variables to solve for x and y. So this is the reason why I had to eliminate the same variable, or this step would not have worked. I can now take these two, like I said, solve for x and y, just like we did in our lesson with two equations and two variables. All right, so to do that, to eliminate. So I'm going to eliminate y in this one. To do that, I'm going to have to multiply the top one by 3 and then the bottom one by -5. Now I chose y over x just because it was easier. I can get a multiple between this 10 and 6 since they're both even much easier and with smaller numbers than I would for the 16 and the 5. All right, let's go ahead and multiply. So if I do the 3 times the 16x, I'm going to get 48x. 3 times 10 is 30, so I get plus 30y. And then 28 times the 3 gives me 84. Let's take care of the -5. So -5 times +5 gives me -25x. -5 times the 6 is going to give me -30y. And then the -5 times the 26 gives me -130. All right, let's go ahead and add those puppies up. My y's are going away. And if I take the 48x and subtract the 25x, I'm going to get 23x. And when I took the 84 minus the 130, I got -46. When I take the -46 and I divide by the 23, I get that x is equal to -2. All right, I have x. We need to find y. I'm going to use this bottom one, again, because the coefficients are smaller than the one above, to solve for y. So I'm going to take this equation. I'm replacing its x with -2, which is what we found, and solve for y. All right, so let's see, 5 times -2 is going to be -10. I need to add the 10 to the other side, so that's going to give me 36. And then, of course, 36 divided by 6 is 6. We have x, we have y. We are now ready to just pick one of our original equations to substitute in that x and y to solve for z. I'm again going to resort to that top equation because, again, he's got the smallest value sitting in front. All right, let's replace x and y. So let's see, 2 times -2 would be -4. -4 plus 6 is going to be 2. And let's see, if I subtract the 2 from the 5, I get 3 and divide by the -1. So z is going to be -3. And we have our solution. Again, remember, you must put it as an ordered triplet in alphabetical order. All right, let's see what this one brings. I still have my three equations. Again, it's a must if I have three variables. I have to have three equations. But notice that these two right here came up a little short. They each only have two variables and Z. All right, let's move him up, make some room. And again, this is what we are going to use to solve. Now, I'm going to bring him over because nothing's changing with him. But notice that I put the y first. And I did that because I like having them in alphabetical order. Okay, they just didn't put it that way originally. Or I guess it just came from me plugging in. So I wanted to rearrange them. Now, this guy, as he stands, will not cancel, and I want to get rid of the z's because that just seems to be the easiest, right? If I'm looking here between the -7 and the 25, there's nothing easy about that. But I can definitely take this top equation and multiply through by 2 to get the z's to go away. All right, so that's what I'm going to do. So 2 times this -7 is going to give me -14y. And then 2 times -2 gives me the -4. And then the 2 times the -19 gives me the -38. And we are now ready to add. Z's go away as I planned. And if I take 25 and I subtract 14, I get 11, as well as getting 11 with 42 minus 38. So 11y is equal to 11. So y is equal to 1. All right, from here, I can go back to my two variable, two equation system and pick one to plug this 1 or y into. He's got the smaller values, so I'm going to go ahead and choose him. I replaced the y with 1, so now I have -7 here. Let's go ahead and add the 7 to the other side to leave me -12. And then if I take the -12 and I divide by -2, I get +6. We are now ready again to pick one of the originals and solve for x. Now I remind you, let's see, it doesn't matter which one I want to use, but he was originally an original, okay? The only thing I did to him was move over the 5y. So I'm going to go ahead and use him because I need x and it's set up very nicely for me to solve for x. So let's go ahead and bring him down. And if I replace the y with 1, it looks like we get that x is equal to 4. And we have now our final solution of 4, 1, and 6. So again, a little complicated, yes, okay, but give yourself some patience, give them a try. They're not too terribly bad once you kind of get in the swing of things. So again, kind of wrapping that up, we're looking to see if I can eliminate something right away. If not, that's okay. Pick two equations, fix them so that something eliminates, and then you got to go back to the third one you haven't used yet and eliminate the same thing. So if you can get yourself down to a two variable, two equation system, you are back to the first day of this unit solving for those two variables and then coming back in the end to plug them in and solve for the last one. All right, now it's time to apply this to a word problem. So here I have Tina's trail mix is a mixture of almonds, cashews, and macadamia nuts. Tina made 21 pounds of her trail mix to sell at the state fair, and it cost her $75.25 to make. Her trail mix contains 3 times as many almonds as macadamia nuts. Macadamia nuts cost $8 per pound, almonds cost $2.50 per pound, and the cashews cost $3 per pound. How many of each ingredient did she use? All right, so the first thing we need to do is identify our variables, okay? And I'm going to use the A for the almonds, C for cashews, and M for macadamia nuts. Now, I know you guys are stuck on X, Y, and Z, and if you want to use X, Y, and Z, by all means, feel free to do that. I don't, because then I forget what I assigned X to and what I assigned Y to and Z. And I'm going to be honest, I'm just like you guys. I don't always write this out on my paper. So if I use variables that represent the item in the word problem, I don't have to worry about getting confused. Personal choice. All right, so again, I can't stress enough that if we have three variables, we have to have three equations. So keep that in mind. We have to come up with three of them. Now, my first equation is what I like to call the physical amount. And what I mean by physical amount is I can touch it, okay? And that's going to be the mixture that she is making. So that is the almonds, the cashews, and the macadamia nuts. So I'm adding those together, and I'm setting it equal to its weight. Right, I'm holding 21 pounds, okay, of this trail mix in my hands. It's the physical amount. All right, I also need an equation that handles the cost. Okay, so they gave me the cost of each pound for the nuts, so I'm just putting that amount in front of the variable. That's going to become the coefficients. So I have my 2.5a plus my 3c plus my 8m, and it's going to be equal to the total cost. So that is the $75.25. So see how it's all related. These are all values in money. It's set equal to money. These are all the items we have. This is how much of them we have. Now, the last equation needs to handle the differences in amount. And that comes up with this statement here, where it says that her trail mix contains 3 times as many almonds as macadamia nuts. Now, when students see this, they want to tell me, hey, well, 3 times, so we're multiplying. Yes, you are correct. That does mean we're multiplying. But you want to tell me that that is 3a is equal to m, because almonds are what come after it. But that is not true. Okay, we are making a statement of equality. So that means it needs to balance out. You always need to get whatever this extra amount happens to be to what I call the little guy. Right now, almonds is the big guy. There's more of them. So I'm going to give this 3 times to the macadamia nuts. So what I really have is A is equal to 3m. Now, I know that sounds confusing, but test it. This is telling me for every 1 macadamia nut, I should have 3 almonds because there's 3 times as many of them. So let's come over here and let's place a 1 in the macadamia nuts. Well, 3 times 1 is 3, so that is leaving me 3 almonds. So this is correct. So I check it here. I also check it in the end, which we will do to make sure that we really do have 3 times the amount of almonds, because I always like to check these and make sure it makes sense in the end. Okay, this is my system. Now we're going to be using the calculator, so if you don't have one next to you, go ahead and pause and go get your calculator. Okay, we're going to use what's called a matrix. Now, to use a matrix, I have to have all of my variables lined up and in the same order. So that means this last equation here is not ready to go. What I'm going to have to do is rearrange them. So I'm just subtracting the 3m to the other side. Now again, they have to be lined up. So here I have A first, then I have C, then I have M, equal to my constant. Here I have my A, my C, my M, equal to my constant. And now down here, I have my A. I don't have a C. I have to have a placeholder, so notice I put a 0, so that's okay. Gotta be there. My M, and now equal to my constant, which happened to be 0. Now, to write your matrix, or what you're going to put into your calculator, it looks like this. All right, so we will, on assessments, ask you to write your matrix. This is the one we're looking for. Okay, this is the one that you're typing into the calculator. Now, notice that I just pulled off the coefficients. So here A is 1, C is 1, and M is 1. Now here's where they're equal to, so it goes on the other side of this line, are 21. My 250, my 3, and my 8, and my 725. Notice here we were missing that C, so I do have that 0 in there, as well as this 0 as well. Okay, so we're just using the coefficients. We take the variable out of it because we're not putting the variables in the calculator, and the calculator will solve this for us. Here's my calculator. All right, the steps to do this. And you should have this on your printout. We are going to use RREF, which is in the calculator, and I'm going to show you how to get there. Step 1 is we need to do second and matrix. So here's second, and here's the matrix. It's a little x to the power of -1. When you do that, it's going to pop up this screen, okay? But we need to right arrow over, so here's my right arrow over to edit, which is what I did already. And you're going to have to hit enter. So when you get it, it's going to be highlighted at names, right arrow over twice till you get to edit, and hit enter. When you do, this is what you should have. Now, you're probably going to have 0, 0 here, and you're going to have to type in the type of matrix that this is. Now, to do that, it's rows, so this is my rows, times my columns. We have 3 rows. Here's one row, here's my next row, and my next one. And we have 4 columns, so 1, 2, 3, 4. Now, I remember what columns are because if you think about a column in your house, it goes from the ceiling to the floor. So columns here do the same thing. They're up and down while our rows are left and right. Okay, so if you have 0, 0 here, you're going to have to hit 3 and enter, and it'll jump you right over to here, and hit 4 and enter. When you do that, you should see this now. Now, I don't see the 4 columns here. It's over here, but the calculator doesn't show it, especially on this old one. If you have a newer calculator, you will be able to see it. They do fit it in. So it just depends on the type of calculator you're using. I always go with this one because this is what we supply you in the classroom. Okay, now we need to put in all of this data. So to do that, you do not need these arrow keys whatsoever. Okay, so please leave these alone. I want you to go to where it's highlighted here, and we are entering this information, and it goes this way, okay, and it automatically jumps you. So if you plug in 1 and hit enter, it automatically puts you over here, and you can do 1 and enter, and again, it automatically scoots you, and you can keep going. Here, when you plug in 21 and hit enter, it automatically takes you down to the next row. So it's very easy and very user-friendly on that part. All right, so once you do that, it should look like this on your screen. Okay, from here, TI did something a little crazy. They want you to go out of this completely. So you're going to have to hit second and quit. Okay, so here's your second button, quit's right next to it. See the quit right here? Now I don't show that screen because it's a blank screen and I didn't feel the need to show a completely white blank screen. From there, though, you are going to have to hit second in matrix again. Okay, so when you do that, you should come to here. Now, you're still going to get the little A, B, C, D here, okay, with the names. You're right arrowing over to math. Okay, so last time we went to edit, this time we're going to math. And you need to scroll down and select option B, which is the RREF. Okay, so here's option B. Notice that A looks a lot like it, only it's missing this other extra R. Well, this other extra R is what makes it do all the rows and solve it. So if you don't use this one, you're only going to get one variable solved, and that's not what you want. So B is best, okay? So you have to go with B. All right, once you hit B, okay, you're going to come back to your main screen, and this just appears. We're not done yet. You have to go tell it what matrix you want to look at. So again, you have to do second and matrix. When you do that, you're here. And we're back at the names. And here's our ABCD again. We entered our information into matrix A. So you'll notice here, I just say to hit enter, and then you enter again. So if I hit enter, because that one's highlighted, you'll come back, this will be here. Here's what the second enter gives you, which is the solution. All right, now this is called the identity matrix. And once we have this, we know that we've got our solution. And this is why you had to keep everything organized and in line when you were setting up this matrix down here. This column right here was our A. Our second column was our C's, which was our cashews. And then this last column right here was our M's. So this is saying, yes, we did have an A, and he equals 10.5. So to write out my solution, I can say that I had 10.5 pounds of almonds. All right, come back up. This column right here was our C's. So I do know I have cashews, and there were 7 pounds of them. And then this last column right here is for my M's, my macadamia nuts, and there's 3.5 pounds of those. All right, a quick check. Obviously, if any of these values had come out negative, you would know that you did something wrong. Okay, we're not going to have a negative amount of one of these nuts in the trail mix. The second thing I always look at is, does it make sense to the original problem? You know, they said that we should have 3 times as many almonds as we do macadamia nuts. Well, if I multiply the macadamia nuts by 3, do I get 10.5? And yes, I do. So this works out just fine. I also remember my weight. All of these added together should add up to 21 pounds. So I also make this extra little check. And if I add these all together, let's see, 7 and 3 is 10, and then the 0.5s will give us that extra 1, that sure enough, we do have 21 pounds. So always do that one extra little check to make sure that you did set up the differences equation correctly. Now this is the only one I am doing here. I am going to have a warm-up when you come back. You will be working one of these, so be ready for that. All right, one more thing before we go. Reading a solution matrix that is not an identity matrix. So this one right here from our last example, he is an identity matrix. And I know that because this diagonal of 1s that we are getting here. Okay, if you do not have the diagonal of ones like this, and let's say here's your 2 variable 2 system equation, well, here's your 3 variable, okay? If you get something like this on your matrix or something like this, so these are not identity matrix, then one of two things is happening. If it leaves you a true statement that you have 0 of something and it equals 0, this is our infinitely many solutions. Whereas if I get a false statement where they're saying, yeah, you don't have any, but there's one false statement, that is no solution. So if these things happen in your calculator, you know how to answer the question. Other than that, we are done for the day.